Hello and welcome to the Miss Grandquist, Miss Mellon show. You're
All
welcome.
right. We're going to start by going over question number 4. And you guys know that when you're doing this, you have to set up first the algorithm. Oh, it's taken a while. And then you also have to set up your chips to show that you have 3 ones, you have 0 tenths, and you have 9 hundredths. One last thing you need to do is show the amount of groups that you're splitting 3 and 9 hundredths into, and you're splitting it into 3 groups. So you need to divide this section up into 3 separate groups. And now we're ready to start with the highest place value and start divvying this place value up. So you can see that we have 3 ones to split between 3 groups. So we can put 1, 1 in each group. And now let's show this on the algorithm. So we have 1, 1 in each group, and we were able to divvy out all 3 of our ones, and we have no remaining ones. Then we can move on to our tenths place. I'm going to bring down the 0 tenths that's there to show that there's nothing there. How do we progress? We just continue to move on to our hundredths place. So we'll bring down the 9 hundredths that are in the hundredths place. And now we can divvy up these 9 hundredths, putting 3 into each group. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we used all 9 of them. So when we look at this, we have 0 in each group in our tenths place, and we have 3 in each group in our hundredths place, and we were able to divvy out all 9 of our hundredths, and we have 0 remaining. So now let's just take a look at where we would put our decimal point. And so we have 1 in each group. Here's our decimal point between the 1 and the tenths place. We have 0 in the tenths place, and we have 3 in the hundredths place, so that decimal would go right between the digit 1 and 0. All right, problem number 5. Okay, so let's go through this one, putting our chips in. So we have 4 ones. We have 1 hundredth. I'm going to put this decimal point in to remind myself that it's there. We have 6 hundredths, and we have 4 thousandths. And we're going to be splitting 4 and 164 thousandths into 4 different equal-sized parts. So I'm going to split this region into 4 sections. And then also be sure to set up my algorithm so that I can update it as I go. Okay, so let's take the first step and start with the highest place value. So let's divvy out the 4 ones we have amongst 4 groups. Well, this is an easy one. We can fit 1, 1 in each group. 1, 2, 3, 4, all of them are used. So let's show that in our algorithm. So we have 1, 1 in each group. We used all 4 ones with no remaining ones. Okay. Now let's move on to our tenths place. Now this is kind of the same situation that we saw as yesterday. How can we split up 1/10 among 4 groups? It just doesn't work. So what we have to do is take this 1/10 and split it into 10 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to use this array to make it more noticeable as 10, a 5 by 2. So now I have, and make a little note to myself, I have 10, 11, 12, 13, 14, 15, I have 16 hundredths at this point that I'm going to divvy up. So I have, again, nothing in my tenths place. I'm going to show that by, let's see, okay, so what I did was I had this 1/10, right, and then I broke that apart into hundredths, and so I combined that with the 6 hundredths that were already there for a total of 16 hundredths. But what I really need to take note of is that there is 0 in the tenths place. 0 in the tenths place. So now I have a combined total of 16 hundredths, and now I'm ready to divvy those up. So I can put, let's see, I have 16 and I have 4 groups. I just know from fast math that I can put 4 hundredths in each group. 1, 2, 3, 4. Oh, it's lagging a little bit. Okay, so I have 4 hundredths in each group, so I'm going to show that. and put the 4 over the hundreds place. So I have 4 hundredths in each group, and I was able to use all 16 of my hundredths with none remaining. Okay. Now we will go over into, we just divvied out our hundredths place. We're going to go over to our thousandths place. And luckily, I can already see that we're not going to have a remainder in this problem. So the decimal is going to stop here. So we can put 1,000th in every group. Okay, we used all 4 of the thousandths. So we have 1,000ths in every group, and we used all 4 of those thousandths for no remaining thousandths. Oops, let's see what happened here. So no remaining thousandths. And so now when we look at our problem, let's take a look and see what our answer is. Okay, so we have 1, 1. We have 0 tenths. We have 4 hundredths. This pen is acting a little funky. And we have 1,000th. So let's talk about where that decimal point would go in our quotient up here. It would go right between the 1 and the 0. So our answer is 1 and 41 thousandths. All right, we have one last one to go over together. It is 338 thousandths split into 3 equal parts. So let me see if I can use a different pen. It's acting up a little bit, guys. So we have 338 thousandths, and we're splitting it into 3 equal groups. So what we need to do is set up our, our chips. We're not using our ones place, but we do have 3 tenths, we have 3 hundredths, and we have 8 thousandths. Okay, so now let's start in our highest place value, and we're going to need to divvy up this section into 3 parts because our divisor is 3. Now we're ready to split it up evenly. Okay, so now let's take these 3 tenths and split them evenly amongst 3 groups. Okay, so now we were able to use all 3, so now let's update our algorithm. So we have 1/10 in each group. We used all 3 tenths, and there's 0 remaining tenths. Okay, so that's the algorithm updated. Now we can move over into our hundredths place. And so let's bring down the 3 from our hundredths place to show that we're dealing with our hundredths place right now. So now let's take a look and divide these 3 hundredths, kind of the same deal here. 1/100th in each group. We used all 3. Let's update our algorithm. So we have 1/100th in each group, right? We have 1 in this group, 1 in this group, 1 in this group. We used all 3 of the hundredths, and we have no remaining hundredths left over. Now we're moving on to our thousandths place. So we have an 8 in our thousandths place that we're going to divvy up among 3 groups. So I know from fast math that I could get 2 in each group to bring me to 6. And I'll have 2 remaining. Okay, I'll have 2 remaining. So let's update our algorithm. We have 2 thousandths in each place. We used 6 of the thousandths to have 2 remaining thousandths. Now here's what gets tricky about decimal division. Okay, you can see looking at this. Okay, this is our tenths place, and so the decimal would come right here. We have 1/10. We have 1/100th, and we have 2 thousandths. And according to this, I'm just going to put the decimal in right here, knowing that we have 1/10, 1/100th, and 2 thousandths. You could keep going into the 10 thousandths place if you wanted to. This is a decimal that I can probably tell you right now repeats and repeats and repeats. Okay, keeps on going. So you could go into the 10 thousandths place and break these 2 thousandths into, you can break them into 20 10 thousandths. So that's 6, 7, 8, 9, 10. Having a tough time keeping up with me. But you guys get the point. So you could continue going and continue to divvy up in the 10 thousandths place. And you'll probably have leftovers. You'd have to take it into the 100,000th place. So with decimals, it gets tricky because some decimals stop and some decimals repeat. This is a decimal example that would continue to go on. So my advice would be to stop at the thousands place, and you can always round to the hundredths place to give yourself a moderately accurate answer. Okay.